Mario Learte.
Hi, I'm Camilo Hernandez.
My name is Osvaldo Finon.
And we're Group 8 of the EEL3110C class.
Hello, good afternoon. We are Group 8. This is our prototype. It's a capacitor tester. We made this project just to try to be easy the work when you need to check a capacitor for AC units or starter motors. In this case, this is only a prototype. In the case we need to work with a high power capacitor, we need to connect it to the source, charge the capacitor, and discharge the capacitor to know exactly if both parts of the capacitor are working properly. In this case, we use a capacitor of 100 microfarads, 50 volts. We use a battery 9 volts connected to the circuit. We're gonna charge the capacitor with 5 volts, and then we're gonna discharge the capacitor, turn on the LED in case the capacitor is bad. It isn't gonna turn on the LED. We measure the voltage on the capacitor on the first stage. Like you can see, it's 0 volts. It's almost 0 volts. And
well, in this case, we have this part, which is the one that is connected to the battery, and that's basically where we got the power. Then the energy goes to the first switch, and then it goes to the second switch. And the main idea of the second switch is to keep minus, minus, and plus, which are the signs that represent the charges of the capacitor and the LED. And the energy is stored in the capacitor in order to pass it to the LED in order to basically work.
okay, how the prototype work? We have the battery, we have the switch. We're gonna energize the circuit. Like you can see, the power it didn't go up because we need to turn on the circuit. The positive is connected to the input of the switch. When we press the button, the positive go through to the switch and go to the capacitor. When the capacitor is charged, we disconnect the source. We have the power, and when we press the button, we discharge the system, and the LED turn on a little time. When we have the 1.6 volts, it's not enough to turn on the LED. But this is basically the prototype. With more power, we're gonna have more time on the LED. But in this prototype, when we press the button, like I'm gonna show you again, we turn on the source, we charge the capacitor, remove the source, turn on the LED. Thank you.
We made a prototype in order to simulate the charge and discharge of a capacitor to test if the capacitor works properly. For example, the AC techs need to check the compressor capacitor often, and the system of single-phase motor starter are also provided with high power
capacitors.
Okay. For these cases where the capacitors are power capacitors, we need to perform a device with the equivalent ranges in volts for the switches and the LED that can support this voltage at 60 Hz. The idea is to provide a final device that the component can work in between 120 volts and 480 volts in 60 Hz without modify the device. Just with a fast connector system to connect the source and to connect the capacitor.
Our prototype also includes a voltmeter to test the voltage in the capacitor when we turn off the voltage source. This is done to check if the capacitor holds the charge until we press the switch to test the discharge, which in turn turns off the LED indicator confirming discharge in the capacitor.